Okay, so um, a lot of these examples are being taken from the textbook because it's extremely time consuming to try to manually draw these out and the computer skills and so on. So I took some that were already done out of the textbook, and they do a good job of serving you, but I didn't take everything out, and this is from section 2.2 in the text. Histograms we'll get to in a little bit, but we're going to talk about frequency distributions first. Frequency distribution table consists of at least two columns, one listing categories on the scale of measurement, X, and another for frequency, Y. So in other words, a frequency distribution table is, all about frequencies. In the X column, values are listed from the highest to the lowest. Always, that's important, worth knowing there, highest to lowest. You're not allowed to skip any. So that means if you have like a zero frequency, you can't skip them. For the frequency column, tallies are determined for each value, how often each X occurs in the data set. These tallies add up to the frequencies for each X value, and the sum of the frequencies should equal N. N is the total number of people in questioned or in the survey. Here's an example. The following is a data set of raw scores. We will use these raw scores to construct a regular frequency distribution table. Notice that the scores are basically in the teens. And this is what your table looks like when you make a frequency distribution table. The left-hand column is the score. There it is. And the right-hand column is the frequency. Script F means frequency. So what this table means, remember, we go from highest to lowest. That's why 17's at the top. And there's one 17. There's no 16s. There are four 15s. Now let's go back to that previous slide. 117. Here it is down here. No 16s. And I think we said there were 3 or 4 15s. 1, 2, 3 15s. Okay? Oh, no, there were 4 15s. I missed one of them. There are 6 14s, 4 13s, 1 12, 1 11, 1 10. And there's a total of 18 scores. If you add up the 117, the 4 15s, and so on, there is a total of 18 scores. So that's why we say N is 18. N is always the total. And looking back here, this is 3 rows high and 6 columns across. 6 times 3 is 18. All right. So that's how you make a regular frequency distribution table. A couple of things worth noting. How does all of this relate to the technical mind-numbing language in the frequency distribution table slide we just read? Well, the first thing is that the categories of the scores are the X and the frequencies are the Y. So you will always get that scores are X, frequencies are Y. That's the first thing you have to know. Frequencies always work out to be the Y in this frequency Y distribution table. The table goes from highest to lowest. We mentioned that before. The frequency is how many times a specific X value occurred. Like there was 117. There were no 16s. There were 4 15s and so on. The sum of those frequencies should equal N. It does equal N. That's by definition, which is the number of scores. And the thing that's important about it is if you add up your frequencies, in this case you come up with 18, and then you look back at the table like we did, say, okay, there are 18 scores in the table, there's 18 here. I most likely got it right. If there were 17, if N was 17 on this chart, the frequencies added up to 17, and there were 18 in the table, you'd have to go back and find the one you were missing. So, frequency distribution tables. A little technical talk here, a little math jargon. A third column can be used for the proportion for each category. P is equal to F over N. The sum of the P column should equal 1.0. This is the point in time where many students' heads begin to split. All they're saying here, this is nothing fancy. It's technical math language for the proportion is part over whole. Okay, that's what we have here. The proportion P is the F, the specific frequency for that one, over the whole. N is the total number of them. So just remember, part over whole. The proportion is the part over whole. That number that they have there, that part, over how many they have altogether. A fourth column can display the percent of the distribution corresponding to each X value. The percentage is found by multiplying P by 100. The sum of the percentage column is 100%. And there we have your more technical talk for what is going on. I'm getting a phone call. I'm going to pause this now and get it going on there.